Inheritance. So inheritance, another major object-oriented programming concept, and it really makes sense that you talk about inheritance after talking about classes and objects. So if you were watching these nuggets sequentially and you took a look at classes and objects prior to that, we saw that a class is just a way that we can model a real-world object. And 9 times out of 10 when you're building an application, you're not just going to have one class inside of your application, you're going to have many classes. And take our car, for instance. If you were to build a class off of a car, sure, you'd have a car class, but think of all the other things inside of a car that could also be its own class, like a radio. A radio is its own object, its own class that could sit inside of a car. And there's tons of things, really. The engine could be its own class. A wheel could be its own class. I mean, you could go on and on. There's tons of them. So the point is here, you're going to have lots of classes that could be interrelated. So that's where inheritance comes into play, because it's going to allow us to create a class hierarchy. And what that'll allow us to do is not only reuse code, but structure our classes in a way that makes sense. So inheritance is the name of the game here. Let's take a look at the outline for this nugget. We're going to start with an introduction to inheritance. Here I just want to get you familiar with some terminology, things like base classes, derived classes, sealed classes, all the different flavors of classes that we can create. And just talk a little bit more about what inheritance is, how it can help us, and then we'll start with how to design class hierarchies on paper. So it's good to get this stuff out on paper. At a high level here, when you're designing your class hierarchies, it's good just to define what classes you're going to define for the solution that you're building. So in the previous nugget, we looked at classes and objects and how you can look at a real-world object and turn it into a class. Well, those are really the details, the properties, methods, and events. Those are the details of a class. Inheritance, we kind of want to take a step back and first define all the different classes that are going to sit inside of our application and how they're related to one another. Then you can kind of zoom in and focus on the details and fill in all the properties, methods, events of each class and determine where they're going to go, because when you have class hierarchies that depend on each other and are of like types, they could go in specific places here. So I'll kind of show you how we can do all that through object-oriented design. And by the way, OOP stands for object-oriented programming. That's kind of the act of actually doing it and programming it. OOD, object-oriented design, if you ever hear that term, is more of getting it out on paper. And it's always good to get this stuff out on paper and flesh it out, because you're really just building directions for yourself, and it's easy to follow directions, right? Well, if you use directions, and you should, because take it from me, I can't tell you how many things the wife has given me to build over the years. I build it, if something doesn't quite look right on it, she's like, hey, why are the directions still in the bag? And I just kind of look at her and say, it's not fun that way. It's fun trying to figure it out on your own. Well, programming, it's not fun trying to figure it out on your own when you're doing it on the fly, because you can get yourself into trouble weeks down the road and have to backtrack a long way. So it's always good to get this stuff out on paper before you actually build it. Alright, so once we get familiar there with how to design things on paper, I'll take you into C#. We'll take a look at just getting familiar with the syntax of how to build these base classes, how to build derived classes, and just get familiar with all the little nuances, and we'll give you again kind of a practical look at this, expanding our person class that we took a look at in a previous nugget, and just showing all the things that we can do with it to make a class hierarchy out of it. And then we'll get into working with inheritance. Here I just want to get you familiar with how to work with casting and how to cast these classes and objects from one type to another. Specifically here we'll look at the is and the as keywords, some awesome keywords that save a lot of time when it comes to casting and trying to figure out what type of object you're actually working with. Alright, let's jump into an introduction to inheritance. So again, what is inheritance? What does it help us for? Well, really, inheritance just allows us to reuse and extend behaviors in existing classes. So it also allows for code reuse, better code grouping. It's easier to manage and understand our code structure. And you can see here what I did is in our classes and objects nugget, and anything that we looked at prior to this nugget, we just had a person class. And our person class contained things like first name, last name, birth date, position, and just basic stuff. And really what that did was that kind of created a very generic person class, because our person could be a character, and we were using Star Wars characters, and it could be an employee. So it was kind of both, because we threw me in there, we threw characters in there, and it's very true that we're all people in that sense. But the problem with that would be, think if we were designing a true person class that had everything in it. We would have to have a lot of crossover between characters and employee, and a lot of data that wouldn't necessarily be related to an employee would still be there for a character, like a salary, for instance, or a hire date. You wouldn't get those in characters. You wouldn't need those. And not only that, but we have a position in our person class. Well, character really doesn't have a position. A character has a role, right? So we could break that out, and using inheritance here, we could create an employee class, and we could create a character class that would both derive from the person class. And the reason we would want to derive it, because we wouldn't want to stuff a first name and last name property inside of employee and a first name property inside of character. Why do that? That's redundant, and that's, we'd have to create the implementation for both of those then inside of both of these classes, and that would be, that would go against code reuse. So what we could do then is put all the general stuff inside of our person class that applies to everybody, whether they're an employee or a character or any of these other classes down here, which don't mind these yet, we'll get there. So things like this, things like first name, as I mentioned here. First name, last name, and maybe birth date. We could all put inside of our person class because those are all common between every single person in existence. We all have those things, right? Now, we could then put the specific stuff inside of our employee class. So all employees then would have a hire date and a position, right? We can start breaking this stuff out. Our character class then, we could do a role rather than a position. Makes more sense. And we could also do homeworld, right? We had that we were working with. That didn't really make sense as far as an employee goes, at least in our day and age. Maybe in the future. But so we kind of break that stuff out, you see? And these are then considered derived classes. All right, so these are our derived classes, otherwise known as subclasses. And this up here would be our base class, otherwise known as a superclass. So this starts the hierarchy off here, our base class, and then down here, our employee would be our derived class. Now, if we wanted to take this a step further, we could. And we could create a developer class and a salesperson class, because these are both employees, right? And now these would be considered derived classes, and our employee would be considered the base class for these derived classes. All right, see how that works? See how our hierarchy is starting to paint a picture here? And we also have a salesperson here, which is also an employee. So we could put salesperson-specific stuff inside of here, methods, properties, events, and developer-specific stuff here. And you see this here? I kind of frame these. These are considered sealed classes, meaning they end the hierarchy. We can't really create any, that I can think of outside of my head anyway, anything else that would derive from a salesperson. Now, developer I can. Software developer or a database developer. And these could be sub-sealed classes or derived sealed classes off of our developer class that could have specific things to software developer, like programming languages. We could have programming languages here for software developer. We could have database languages here for developer. And this is where things really start to get interesting, because really we could put what would be considered an abstract property in here called languages. And then we could have different implementations down here where this would only support database specific languages. This would support software languages, And I'm getting a little ahead of myself, because now that's where we're starting to get into polymorphism and such, where we're starting to have same kind of different behaviors, same behavior with a different type of implementation. But we'll get into that when we get into polymorphism. Just wanted to touch on that there. But for now, let's just say we'll have software languages and database languages in here. So they're specific versions of languages within each. But the point here is, getting back to our hierarchy here, we've got our base classes on top, and then our derived classes that get all the functionality that the base class has, but can also extend it with its own functionality. So we've got base classes down, derived classes down, sealed classes. Let's talk about abstract classes. See how I have this dotted line up here around person? I did this to denote that this is an abstract class. And what that means is that you cannot create this class as a standalone class. So we couldn't create an object of a person class like we have been doing in previous nuggets. We created an object, initialized it, and started using it. Well, if we made that person class abstract by just tagging it abstract class in the name of the class, you cannot directly create an instance of it. It's purely there to define all of the base properties, methods, and events for everything that's going to derive from it. So you do this if you wouldn't want anybody to create a person class, if it wouldn't make sense. Like it wouldn't here. You could create an employee that would contain everything that a person has, and a character that contain everything that a person has, but you can't create a person by itself. Alright, so that's what abstract classes are all about. And this is actually a good implementation of this, and I'll show you when we get into our nugget here. We'll actually take our person class, make it abstract, and then create these derived classes off of it that we then can create more derived classes from. So that's inheritance, and again, what inheritance really does for us, it promotes code reuse, number one, because if we were to create in our person class a talk method, guess what? All of these derived classes would then get a talk method that we would just call, and they would call the talk method on the person. So we write that code once inside a person, everything underneath it that's derived off of it gets it. That's awesome as far as code reuse goes. And code structure is the other big one that we get some help with here, because it's much easier to work with these classes individually than if we were to just have one big honking person class with all this stuff in it. Especially if you're working in a team, other people are probably going to use your code if you're designing these classes, whether it's for the current project or future projects. And if they're gonna if you're gonna have one big huge honking person class with character and employee data, and they're trying to build, and maybe even customers in it as well, and they're trying to build a customer service application, and they're creating our objects, and all of a sudden they see object dot homeworld for a customer service app, they're going to get confused. So code separation is huge. It gives our application more structure. We get code reuse. Just a lot of benefits here to working with inheritance and breaking things out. And one thing I used to do when I was learning this stuff, I used to love to take my favorite sci-fi universe and try to make a class hierarchy out of it. It's a great practice. For instance, I did this sort of generic on purpose here, because think about, and I'll just take Star Wars as an example because it's probably one of the biggest ones out there. But if you were to really break out and try to take all the characters in Star Wars and make a class hierarchy out of it, you'd probably first, because you have humans and aliens, start with just a standard life form base abstract class. I'll get you started here. So a life form abstract class, because you can't create a life form, it's got to be some kind of a life form, right? So you could create a life form as your abstract class, and from there you could branch off and create human, create alien, and then you could go from there. All right, I'll let you try to figure that one out yourself. And by the way, tip, you can do abstract classes off abstract classes. So you could do a life form abstract class followed by a human abstract class and an alien abstract class, and then you could start making your concrete classes. And by the way, that's another word for both of these sealed classes and derived classes. Anything you can create an instance of would be considered a concrete class, where an abstract class is not concrete because you can't create something of it. All right, what do you say we jump into C# here and get familiar with this? So we've got our directions here. Let's follow them the best we can and try to make something of it. So let's minimize whiteboard, head over to Nugget Lab, and in here we're going to head down to Start, up to C# 2010, and I've got a solution in here, 07-inheritance. There it is. We'll fire this up, and I've left this pretty much in the same shape it was in the classes and objects nugget. We've got our person class, which I didn't do much to. I might have just cleaned it up a little bit, make it a little more readable as far as the comments and things go. But other than that, I didn't really touch it at all. So we're going to take this class, we're going to make some derived classes off of it, and then we'll turn this one into an abstract class so we cannot create an instance of it. Because right now, over in our inheritance form, right here, if we look at the code behind, you can see we're creating this person class as a new person, and that's how we're using it. Everybody's just a person right now. So it's our job to break this person out into specialized, an employee, a character, and then maybe we'll even take some things off of those as well when we get there. So let's head over to our person class. And the first thing we need to do here is just identify what doesn't belong in a person class, because we want this to be as generic as possible to cover, again, anything from an employee to a character to a student to anything else that could be derived from the person class. So just scrolling down here and looking at the properties, we can tell right here, position and homeworld don't belong here. First name, last name, and birth date, absolutely, because those are all common things that a person would have. So that looks good. Everything else is pretty generic in here. Every person's going to talk and can sleep and wake up, and everything else looks pretty good here. So let's create an employee class that derives from this person class, and then obviously here we'll extend it to support employee-specific stuff. So let's right-click on classes, head over to Add, choose class, and in here let's just type in employee. Hit Add, and there we go. We now have an employee class. Now what I'm going to do here is just copy the namespace, and by doing that I kind of destroyed our previous copy there, so we'll just type it out though. Alright, so now we're involved in that namespace. Now what we need to do, if we want to derive from a base class here, all you do is type a colon after the name of your class, followed by whatever your base class is going to be, the class you want to inherit all of the functionality from, and that is going to be person. There we go. So right here, without doing anything, if we just go and start making employee objects, we would automatically get everything that's in person. If we did, employee dot, we'd get first name, last name, birth date as choices of properties. We'd be able to invoke all of these parameters or all these methods and everything. So right now, it is an employee, but it's really just all the functionality of a person. So if we wanted to extend it, now we can just start adding properties to it. So let's add a position in here, right? And this will be our get and set here. There's position. And then let's add a hire date. How's that sound for employee? Everyone's gonna have a hire date more than likely, so we'll get that in here. And looks good. There we go. We've got an employee. Now let's do the kind of quick and dirty way to test this out here. If we head over to our inheritance code behind for our form here, let's just go inside of the load event and test some code here. Let's type employee as a data type, e as a variable name equals a new employee, and then if we do an e dot, check it out, there's our hire date. Scroll down, there's our position, plus we've got everything that our base person class has available to us. Only we're working with our derived class employee. So pretty cool there. And one thing I do want to point out, however, is when we created a new instance, see this employee.employee, we don't have the constructors that we created in our person class. Remember we created this constructor so you could initialize it with the first name and last name? Well, we don't have that, and this, by the way, isn't required by anything. You won't see this in the exam or anything. I just want to kind of point it out because it's very useful. What we need to do is what's called constructor chaining. So we can do that by creating a constructor in here that kind of mimics it. So we'll do public employee, and then we need a string here for first name. We need a string for last name. And here's the fun part. And if you actually just put a colon after here, followed by the word base, and check it out. Now we get the constructors in our person class available to us. So we're kind of creating a pass-through, because now we can just do first name, last name, and it's going to pass that data if they were to, if someone were to use this right now, create the employee class. In fact, if we just go back to our form, and let's just retype this, check it out. There it is. So now we could pass in a first name and a last name, and that'll get passed right through into our person class, and it'll get initialized. And the nice thing about this is in our employee class here, you could put extra initialization code for an employee inside of here. So it's kind of nice. You can initialize your employee differently than you can initialize your people using this method. And if not, then we still support exactly what our person class was set up initially for. Alright, let's create our character class here, and just to get another one in here, I'm going to right click on classes, head over to add class. Let's call this one character. Hit add. And I'm just going to change the namespace here again so we're all matched up. Oop, that's not our namespace. Let's head back over here quick and just copy this. There we go. Alright, perfect. So our character class, what would we want to track here that would make it a character? Well, let's do role. Looks good. Getting set. And then how about, what's another one here? How about homeworld? Yeah, we had homeworld in there. Homeworld with getting set. So the only thing left to do with this class is derive from the person class, because right now we just have a character class that supports role and homeworld. We want it to have all the person stuff just like our employee class does, so we need to put a colon followed by a person. There we go. Now we've got everything the person class has as well. So the next step is to start using these classes, and what we're going to do is we're going to convert our inheritance form here so it can work with all these different types of classes. And I modified this list a little bit. We're going to use this column here for either position or role. So we're going to need to do a little logic here to figure out what kind of person we're dealing with when we're loading this list up, because we need to pull the position property out if it is an employee, but if it's a character we need to take the role property out. So we need to do some decision making there, so we'll get some logic in there. And then also down here we'll examine the type of person that it is and output it to this column here so we know if it's a character or an employee. So let's head over to our inheritance.cs form, and let's just head on down here, because really load people is and I haven't touched this code at all since the last nugget, the previous nugget when we talked about creating classes. So we need to modify this to now support our new design. Alright, so let's do that. Let's make Skywalker here a character. There we go. I'm just going to copy and paste this here. Same with Vader. And then myself, an employee. There we go. Oop, that copy didn't work all that right. There we go. Employee. So now if we scroll down here, we see we don't support position for our character classes. Instead, that should be role, and homeworld should be supported. We actually have a bug here going on, and that bug is if we head over to our character class, we just have these defined as a string. If you look at our employee class, we have a public followed by that. That's the access modifier, and we're going to cover those more when we get into encapsulation. But we need to do that, otherwise they're going to default to private, meaning these properties are only accessible within the character class, so within these brackets here. So making them public, now if we head back to our form, see that homeworld lit back up. So we're good to go. So let's change position to role. Same with our second one, our Vader class here. And now they're all set. So the only thing we need to do now is our employee class. We need to take homeworld out, and let's just replace this with, we need a hire date in here, so I'm just going to copy birth date. Just like so. We'll change this to hire date, and let's just change the year there, and that should be good to go. Now, we got one more bug to work out here, and that is because we defined in our employee class a constructor, we don't have a default constructor. So we could add a default constructor. Let's just take this out for now. I just wanted to show you there a little bit about how you can do constructor chaining. But now if we head over to inheritance, check it out. All of our person classes have now been transformed into their specialized derived classes. So the next step is working with these classes in code, because we've got one kind of a generic method here that accepts a person class that we're going to load all these people, and we need to extract the right properties out of. So this is where casting is going to come into play. And this is okay. You can take a character class or an employee class or any derived class and pass it as a, into a variable that is of the base type. And this is okay. And you're not going to lose any data doing this. This, just by passing it in, is going to do an upcast inherently. So basically what an upcast is when you're going up the chain. You're converting something up the chain. And it's not going to lose data. You're just not going to be able to access that data if we hit the P. And you notice that's why p.position and p.homeworld says, sorry, person doesn't contain a definition for those. And in the right, it doesn't contain a definition. Employee and character do. So, even though we pass it in as a generic person class, it's still, we could reconvert it to a character and employee class and get all that data back. And we've got a couple of different keywords that'll help us with this conversion stuff. In fact, let's just get these two things out of here, because we're not using homeworld anymore. You see, I took homeworld out of here for now. But position and role, we need to extract those depending on the type of person that it is. So what we can do here, let's just do a character C equals P as character. All right. And what this does, the as keyword, what that's going to do is it's going to attempt to convert this P to a character. So it's going to attempt to cast person to a character. Now, if for some reason we had an invalid cast here, rather than the .NET Framework generating an error, it's just going to stuff a null value into this variable. So that's why we need to do a null check. So all we need to do here is do this. If C does not equal null, then what we're going to do is just an LVI person. Alright, here, LVI person dot subitems dot add, and we're going to add in a C dot role. Alright, see how that works there? So because this is a kind of it's doing two things at once. It's doing the conversion. If the conversion fails, it's going to stuff a null value into here. If it succeeds, meaning it's not null, there's not a null value, then we're going to get the actual person class converted to a character class that we can then use all the specialized data stored in that character class. Cool, right? So let's do the same thing with employee here. Let's just create an employee. We'll call it E equals P as employee. And we'll do the same thing here. If E does not equal null, then let's just copy this up here, paste it down here, and let's do an E.position. There we go. So one of these is gonna happen. If it pass a character in, it's gonna be a character class here, converted as a person class, or it's gonna be an employee. So whichever one it is, it's gonna add that specific one. It's either gonna add the character's role or the employee's position to this appropriate column here. So that's as, and I love as. As is a great way to do conversions and to do casting, because it's a lot easier than using exception handling and wrapping things in structured exception handling, try to catch invalid conversions and all that, because it just, if it can't convert, it'll just put a null value into here, and then you just check for null. That's all there is to it. Very simple. Now the other one we have is the is keyword. So let's just do this, and this is going to be for the last column here, because we need to figure out the type of person that it is. So what we're going to do is an LVI person dot subitems dot add, and we're going to say P is character. Oop, not char, character. There we go. And I'm going to blow your mind a little bit here. This is a shortcut notation for an if. Alright, so I'm going to do character, and I'll explain this code. It's actually really straightforward. Employee. That's it. That's the whole code. So what this is this is actually an if statement in one line on the fly. This is really cool, because what we're doing here is this is your condition. So pretend here's an if statement. This is our condition wrapped inside of parentheses. P is character. So if it is a character, it's going to return true. If it's not, it's going to return false. So this is a question mark. Think about, this is the question that we're asking is our condition prior to the question mark. After the question mark, we have the true part followed by the false part. That's all there is to it. So then you separate it here with a colon. So if P is a character, then the true part is it's going to add the word character to the list. If it's not, it's going to add the word employee to the list. As simple as that. So that's the nice thing about is you can just kind of do a test, a Boolean test, to see if it's a type or not. Alright, what do you think? Should we test this out here? Let's go ahead and hit run. Make sure everything looks good. There it is. Check it out. So everything happened accordingly. In fact, if we set a breakpoint here, and let's just stop this and run it one more time, you can start to see here right now C is null. If we hit next, check it out. Now C is a character. So we successfully converted that person from a person to a character, because that's what it was when we created it. We just passed it in. It got upcast to a person, and then we downcasted it back to a character, and we didn't lose any data because it initially was a character. And you can see, if you hold your mouse over C here, there's all that data. Home world, role, and then their base type. See that? This base type is their person. So this will contain all of their person data then, because that is our base type. Now let's do one more thing here. Let's add a salesperson into the mix. That is also going to be an employee. So instead of deriving from the person class, we're going to derive from the employee class. So let's add a new class. Let's call this salesperson. Hit add, and we need our oop, that's not it. There we go. We need our namespace in here. There we go. And now this is going to derive from, again, employee, because a salesperson is an employee. And another thing I want to do here, let's mark this class as sealed, because we're at the end of the inheritance chain for this branch here. We don't want anybody ever to create any derived classes off a salesperson. So there we go. That's why you can add sealed there. And we'll take a look again more at these access modifiers when we get into encapsulation. So let's make a property here. Public int, how about total sales? That looks good. We'll just do a get and a set, and that should do it. Alright, so now all we need to do is just modify, go back into our inheritance form here, and we're just going to modify this. In fact, we really don't need to do anything here, because a salesperson is an employee, so they'll still get their position added. Let's just go up here and make a salesperson. There we go. So I just copied my record in here. Let's just add John Doe in here. John Doe, position, we'll just say sales. We'll add everything. We'll leave everything else the same. We'll call this salesperson, then we need to actually make it of type salesperson. Oop. There we go. And let's just copy my record here, add salesperson in there, and there we go. So, and then we could add our total sales in here as well if we wanted to at the end. Now that we support it, there it is, total sales equals, and this is an integer here, so let's just do something like that. Alright, so that's really all we need to do. Everything else will flow in here. The only thing, if we wanted the type to show up as salesperson, we need to expand this and add kind of a nested, what they call intermediate if. This is an intermediate if statement here. A nested one inside of here. So what we would do is say if P is employee, then yep, we're going to type in employee. If it's not an employee, then the only other thing it could be is a salesperson. So we'll just type in salesperson. There we go. Just like so. So now if we run this, we should get John Doe, sales, and oh, he's an employee. What happened there? Something went wrong with our code there. Should have said P is employee, true part is employee. Oh, you know what? Because P is actually an employee. It's a salesperson, but it's still an employee. So we need to do something like this. Salesperson is, we just need to reverse these here. Salesperson is an employee, but an employee is not a salesperson. That's exactly how I should have said that. So now if we run it, check it out. Salesperson, see that? So P.is kind of did a cast on the fly just because a salesperson is an employee, as I mentioned, but an employee is not a salesperson. That's how that works. So that was kind of a good unintended, lesson there on that. That's why I like doing this stuff live, because you can really see the power of doing this stuff on the fly. This is all the kind of stuff you're going to encounter in everyday programming is stuff like that. So be aware of that, because that's huge when you're working with inheritance and derived classes, that when you're doing stuff like this, make sure that you're looking at it in the right light. See, I totally looked at that in the wrong way, because again, a salesperson is an employee. Alright, the last thing I want to show you here is a little bit of abstraction. How we can make an abstract base class, or an abstract class at all. It doesn't have to be a base class, but just an abstract class. Because what this will allow us to do is, again, create something very generic. And if we do not want anybody that's using our classes here, including ourselves, to create a person class, because it wouldn't make sense. If you're only dealing with employees, or if you're only dealing with characters, you're only dealing with a specific concrete style class. For instance, say you're storing this stuff inside of a database. You don't want to, you can't store a base person class. It has to, maybe, you require all that extra data because you have an employee table that you're tracking employees. So in that case, we wouldn't want to allow anybody, including ourselves, to create a person class by itself. It would need to be a specialized class. And you can do that just by adding the word abstract after our scope here. So public abstract class person. So now we could not create an instance of the person class. We can only create and access anything inside of the person class, all this functionality, through a derived class. All right, so through any of these other three classes that we created. And so how this worked, just adding that abstract there, if we head back over to our inheritance form, check it out. Now we've got an error over here that says, hey, sorry, you know what? You cannot create an instance of this abstract class. So what we need to do is just take this off of here. And the reason this will work for us is because we're not using this person class in any other way here. We're calling currentPerson.sleep currentPerson.awake, but you know what? When we select an item in the list here, it's going to be a character, employee, or salesperson that we've converted to a person. So even though we're converting it to a person, it's still that specialized instance of a class. So we can call sleep, awaken, things of that nature, talk, and it'll actually call the derived classes function, not going to try to call the person classes function. You can see this if we hit run and we click on any of our class here and hit talk. See that? It worked. That's because it's actually calling the derived classes function, not the base classes function. And we'll talk about how we can control all of that when we get into polymorphism here, because that's just kind of one of those things, because when we created the class down here and stuffed it into the tag property, it is an actual character or an employee or a salesperson, even though we're converting it to a person and storing it as a generic person object up here. So when we reference and call these functions, it's still going to call the actual functions on our derived classes, because that's what it is. But again, we'll talk about a little bit more in detail about that here when we get into polymorphism. But the best thing to take away from this here is again here, that's really inheritance. As far as you can go with inheritance, it's most of the work in inheritance isn't building these classes, but it's designing them and designing your inheritance hierarchy. So building it becomes pretty easy again once you have it on paper, because it's just a matter of creating your classes, deriving from the classes that are above it in the hierarchy, and then adding your specialized properties, methods, and event for your specialized classes. Alright, so in this CBT Nugget, we took a good look here at inheritance. We started off with just a kind of an introduction to inheritance, what it's all about, how we can create an inheritance hierarchy, and just got some terminology down here: base classes, derived classes, sealed classes. Talked a little bit about abstract classes, and then I got you in here to a demo. And we took our person class we developed in a previous nugget, and we broke it out and started creating our specialized classes such as employee, character. We derived from our base person class, so we inherited all that functionality, and then just took a look at how we could work with it in code there and do things like upconverting or upcasting as they call it, and downcasting, and then using the as and is functions to help us along with that. And at the end here, I just showed you a little bit about how to create an abstract class. I hope this has been informative for you, and I thank you for viewing.